In Lesson 2.2, we're looking at a brief overview of triangles. And so here again, we've got some more vocabulary. We have triangles that are classified by sides and by angles. And these first two are a classification by sides. So for a triangle to be scalene means no sides are equal. Notice all three sides are a different measurement. For a triangle to be isosceles, two sides must be equal. Okay, so we've got two sides here equal. And notice at the same time, that means two angles must be equal. Okay, the angles opposite those sides. And then an equilateral triangle is all three sides are equal. So here we've got 5, 5, 5. But notice that the angles are all equal as well. And that's a very special idea here, that those three angles are each 60 degrees. And then our last one is a right triangle. And notice this right angle little symbol here telling us this is a right triangle. And you do need to recall that the hypotenuse is always opposite the right angle. Now, let's see if I can get it going. We looked at that equilateral triangle and said, oh, all three of the angles were equal. Well, this is a very important fact in triangles, that the three angles of any triangle add up to 180 degrees. Okay, so no matter what type of triangle it is, where it's right or scalene or equilateral, it doesn't matter. The sum of the three angles always has to equal 180 degrees. So here we've got a quick little video demonstration. Notice that they're pulling the point and the three angles always add up to 180 degrees. Regardless if it's obtuse, acute, the three angles must add up to equal 180 degrees. And they're going to pull this last point here. Okay. Let's see. Lost my cursor here. Okay, there we go. Now, with triangles, we also have two other terms that we need to consider. A triangle is a three-sided polygon made from three straight line segments, and we have a base and an altitude. Well, you can choose any side of your triangle that you want to as the base. Okay, notice here that we've got three different sides labeled here for the same triangle as the base. The altitude is going to be drawn from the opposite vertex to the base, and it's always perpendicular. Okay, so if the base is located along the bottom of the triangle, then you start at the opposite vertex and drop it straight down, and so on. It's always perpendicular to the base. And to show perpendicular, remember we're going to put that little box there that shows us it's a right angle. Some other important facts is we need to be able to figure out the perimeter and area of a triangle. And the perimeter is just the distance around. Okay, so that just means you add up the three sides. The area of a triangle, however, is this formula, 1/2 base times height. That's the formula for area. Another way to find area, if you have all three sides given, but you don't know a right angle, it's not a base and a height, is called Hero's formula. And in Hero's formula, the area is defined as this, the square root of, let me go back that up, the square root of S minus A, S minus B, S minus C, where S is 1/2 of A plus B plus C. So this is another way to find the area of a triangle if you don't know a base and a height. Okay, so in this triangle, it's a right triangle, and one of the key things you probably remember from geometry is that in a right triangle, you can take the sum of the squares of the legs, and that equals the square of the hypotenuse. Or in other words, a squared plus b squared equals c squared, provided that c is the hypotenuse, okay? So in this particular problem, we want to find the length of B, and we've got A and C given. So to do that, we're going to just plug into our little formula here. So we've got A squared, that is 5 squared. We're looking for B, so that's plus B squared, equals C squared. And that was 13. That was the hypotenuse. So the rest of this is a matter of solving algebraically. So 5 squared is 25, and 13 squared is 169. So our next step is 25 plus B squared equals 169. And then we need to get rid of this plus 25, so we subtract 25 from both sides. So B squared equals 144. And then to solve for B, since B is being squared, we want to take the square root of both sides. So our answer for B is the square root of 144, which is, I'll just write it down here, square root of 144, which is 12. So the length of side B is 12 centimeters. And the last thing that's mentioned in lesson 2.2 are congruent and similar triangles. Now, for two triangles to be congruent, they have to be identical. It's like you cut one out and you can place it right on top of the other. So in this particular drawing, the first two triangles are congruent. Same size, same shape. Now, the similar triangles are the same shape, but they're not the same size. It's like you've taken the smaller one here and enlarged it by a factor to get this triangle, whose sides are 10 and 5 inches. So the idea here is that 4 compares to 10 as 2 compares to 5. And they've kind of listed it over here for you as well. If you have two triangles ABC, you want to compare side AB to side A prime B prime, side BC to side B prime C prime, and side AC to side A prime C prime.